Most moons are silent and lifeless, but one world in our solar system erupts hundreds of times every day. That world is called Io, and it is the most violent moon we know. At first glance, Io does not look extraordinary. It is about the same size as our moon, a rocky sphere orbiting far from the warmth of the sun, a place that should be frozen, cold, silent, dead. But Io is anything but quiet. Orbiting above it is Jupiter, the largest planet in the solar system. A giant so massive it dominates the entire region of space around it. From the surface of Io, Jupiter would fill the sky, a swirling wall of clouds stretching across the heavens, and its gravity never stops pulling. Io circles Jupiter at a distance of about 350,000 kilometers, a journey that places it deep within the gas giant's immense gravitational well. On a cosmic scale, this isn't much farther than the distance between Earth and our own moon, but the comparison ends there. Jupiter is over 300 times more massive than Earth, and the gravitational pull here is vastly stronger. If Io's orbit were a perfect circle, this pull would be constant, but it's not. Io is locked in a gravitational dance with two of Jupiter's other large moons, Europa and Ganymede. Their periodic alignments give Io a gravitational nudge, forcing it into a slightly elliptical path. And because of this, the immense pull from Jupiter is constantly changing. As Io moves through its orbit, Jupiter's gravity relentlessly stretches the moon. The side of Io closest to the planet is pulled harder than the far side, creating a massive tidal bulge. The entire surface bends outward, then relaxes as Io's distance changes, then stretches once more. This brutal cycle of flexing repeats every 42 hours, generating tremendous friction deep within Io's core and mantle. This process, known as tidal heating, turns the moon into a planetary-scale furnace, melting rock into magma. The effect on the surface is staggering. The ground on Io rises and falls by nearly 100 meters with each orbit, a tide of solid rock. Imagine the entire crust of a world flexing like rubber, mountains slowly lifting, valleys sinking, and deep underground rock grinding against rock. All of that motion creates friction, and friction creates heat. Enormous amounts of heat, enough to melt rock deep beneath the surface. The result is something extraordinary. Io is covered in volcanoes, not just a few, hundreds. More than 400 active volcanic centers have been detected, making Io the most volcanically active world in the solar system. Some of these eruptions are so powerful they launch lava dozens of kilometers into the sky. Above that, giant plumes of sulfur gas can rise hundreds of kilometers higher. For a brief moment, parts of Io literally erupt into space. From orbit, the moon looks painted, bright yellows, deep reds, pale whites. These colors are not minerals like we see on Earth. They are sulfur compounds, deposited by volcanic eruptions across the surface. Where temperatures drop low enough, sulfur crystallizes, forming yellow frost across the landscape. In colder shadows, frozen sulfur dioxide collects, creating patches of white and blue ice. And where eruptions are fresh, the ground glows red with heat. But the volcanoes of Io do not behave like those on Earth. While our planet's volcanism is driven by internal heat and plate tectonics, Io's is a direct consequence of the immense gravitational forces exerted by Jupiter. This constant tidal flexing generates incredible heat deep within the moon, creating a global subsurface ocean of magma. The result is a volcanic style utterly alien to our own experience. Here, you will find no towering volcanic mountains, no massive cones like Mount Fuji or Mount Etna, built up over millennia by thick, viscous lava. Io's magma is far more fluid and erupts with such frequency that any mountains would be quickly buried. The entire surface is constantly being repaved. Instead, lava often erupts from long cracks in the surface, known as fissures. These can stretch for hundreds of kilometers, splitting the crust as it's pulled and stressed. Molten rock, superheated to over 1300 degrees Celsius, pours out. It spreads across the ground in enormous, fast-moving lava flows that can cover areas the size of entire countries on Earth. When a vast magma chamber below empties, the unsupported surface collapses inward, and something new forms in the resulting depression. Giant lava lakes, vast active pools of molten rock, slowly churning beneath a thin, dark crust that constantly fractures and founders. The largest and most famous of these is Loki Patera. At nearly 200 kilometers across, it is a sea of magma, larger than many cities on Earth. This colossal lake exhibits a strange periodicity. Every 500 days or so, a wave of crustal overturning sweeps across its surface, causing a massive surge in thermal brightness visible even to telescopes on Earth. It's a predictable, rhythmic cataclysm on a planetary scale. But the deeper scientists look at Io, the stranger it becomes, because despite all the lava, Io does not appear to contain a global magma ocean. Instead, the molten rock seems scattered, hidden in isolated pockets beneath the crust, each one acting like its own volcanic engine. This means every volcano on Io behaves differently. Some erupt violently, others simmer quietly, and some remain silent for years before suddenly exploding. But the mysteries of this tortured world do not stop with its fire-breathing volcanoes. The landscape itself holds even more profound secrets, because scattered across Io's otherwise flat, volcanic surface are enormous mountains. These are not the familiar rolling ranges we see on Earth, formed by the slow collision of tectonic plates over eons. Instead, they are colossal, isolated monoliths. Some rise more than 18 kilometers high into the thin atmosphere. That's more than twice the height of Mount Everest, thrusting up from a world with much lower gravity. And these mountains do not form in chains or ranges. They stand utterly alone. Isolated spikes rising abruptly from the landscape, like colossal shards of a broken world. So how do they form? It seems they burst from the ground without warning. Scientists believe these mountains are created by the immense stresses within Io's crust, a direct consequence of the same tidal forces driving its volcanoes. As vast reservoirs of molten rock drain away beneath the surface to feed a volcanic eruption, the crust above loses its support and begins to sag and collapse under its own weight. This subsidence places enormous compressive stress on the surrounding crust, forcing adjacent, massive blocks of rock to be pushed upward along deep faults. This process isn't gradual. It happens suddenly, violently. In a single, catastrophic tectonic event, a mountain is born, creating massive cliffs and towering jagged peaks that scar the face of Io. The result is a world that never stays the same. Old lava fields are buried by new eruptions. Mountains rise, then slowly crumble. Entire landscapes are erased and rebuilt, again and again. All of this chaos is powered by gravity, not heat from the sun, not radioactive decay, but the relentless pull of Jupiter. Every orbit stretches Io like a rubber ball, squeezing its interior, pumping energy into the moon, fueling its volcanoes, and reshaping its surface. In many ways, Io is not just a moon. It is a machine, a gravitational engine, powered by the immense force of the largest planet in our solar system. And yet, despite everything we have learned about Io, we have barely explored it. Most of what we know comes from brief spacecraft flybys. Voyager, Galileo, and more recently, NASA's Juno mission, each one revealing only fragments of the story. Juno's recent close passes gave us some of the most detailed images ever taken of Io. And what they revealed was astonishing. New eruptions, fresh lava flows, and landscapes that had already changed since the last observations. But Juno will not stay forever. The spacecraft is slowly running out of fuel, and soon its mission will end, leaving Io once again alone in the darkness. For now, no spacecraft is scheduled to orbit this extraordinary moon. Future missions are focused on other worlds, Europa, Ganymede, places where oceans may hide beneath frozen crusts, where life might exist. Io offers no such promise. Its surface is too violent, too unstable, too hostile. But in another way, that is exactly what makes it fascinating. Because Io shows us something profound. Gravity alone can transform an ordinary moon into a world of fire, a place where rock melts, mountains explode from the ground, and volcanoes reshape the landscape endlessly, far from the warmth of the sun. In the cold darkness of the outer solar system, there exists a moon that never stops erupting and never truly rests. Io, the most violent moon we know,